Here is a numerical type question. Work through the numbers carefully. Let us solve it step by step. Let us begin solving this step by step. Identify the structure. The compound is CH3, CH is equal to CH, Br, CH, Cl, CH3, which is 4-bromo-5-chlorohex-2-Na. Moving on to the next step. Identify stereocenters. A stereocenter, stereogenic center, is any element that, when its groups are interchanged, produces a stereoisomer. This includes both chiral centers, sp3 carbons with 4 different groups, and the carbons of AC is equal to C double bond that give rise to geometric, EZ, isomerism. Moving on to the next step. Analyze the double bond, C2 is equal to C3. C2 has groups, CH3 and the rest of the chain is equal to CH. C3 has groups, H and the rest of the chain. Both carbons of the double bond bear two different substituents each, so the double bond is capable of EZ isomerism. Each carbon of a geometrically restricted double bond counts as a stereocenter. Therefore, C2 and C3 each contribute one stereocenter, giving two stereocenters from the double bond. And for the final step, analyze C4, CH with Br. Its 4 substituents are Br, H, CH is equal to CH, CH3, the alkenyl chain, and CH, Cl, CH3. All 4 are different, so C4 is a chiral center, one stereocenter. Analyze C5, CH with Cl. Its 4 substituents are Cl, H, CH, Br, CH is equal to CH, CH3, the chain toward C4, and CH3. All 4 are different, so C5 is a chiral center, one stereocenter. Total stereocenters is equal to 2, from C is equal to C, Ez, plus 1, C4, plus 1, C5, is equal to 4. Therefore, the correct answer is 4. Therefore, the correct answer is 4.